In today's video, we're going to be taking a look at a multi-class classification problem, more specifically the iris dataset, which we're going to extract directly from scikit-learn. And to analyze the data, we're going to be using PyTorch. And also to say that this is one video in a series of many videos that I'm making on PyTorch and also deep learning. So if you're here to pick up these skills, a little bit of Python skills, you are in the right spot. I'm going to go line by line, explain everything that I code out, so that way you can get familiarized with a lot of the different concepts, because I know when I first started learning PyTorch, I was confused quite a bit, and I felt like a lot of videos didn't explain that well. With that being said, I'm going to be using something called Google Colab, and let's start coding. All right, we have Google Colab set up. Now let's import in a few different libraries. So first thing, when you're working with PyTorch, you're going to need Torch all the time. So import in Torch like that. Next, what we're going to do is import torch.nn. We're going to create a class later that inherits from torch.nn. So make sure that you have that over there. Now we need our optimizer. So import torch.optim as optim. And I forgot over here, make sure we put this as an n like that. Okay. Now we're going to take a look at a few different imports from scikit-learn. So from scikit-learn.datasets import load iris like this. Okay. Then we're going to get from scikit-learn.module selection import train test split. All right. Then what we're going to do is preprocessing. So from scikit-learn.preprocessing import standard, which is capital S, standard scalar like this. Okay. Then we're going to say from sklearn.metrics import in our accuracy score. So accuracy like that. Score. Okay. Now we're going to import in pandas. The only reason why we're going to import in pandas is I just want to show you how some of this data is represented. And we're going to import in matplotlib.pyplot as plt, and I'm going to do as pd over here. And I think if I didn't make any typos, this should be it for this specific cell. Let's run it. I do shift and enter, runs it, and then goes down below. And it might take a second. But while that loads over here, we're going to bring in iris. So all we have to do is say iris equals load underscore iris like this. Okay. Now our iris will be over here. And now you want to set up your X and your Y. So you can just say X equals iris.data. And then you can say Y equals iris.target. And now you have this set up. So pretty easy just to see what's going on. You can just put in your X and Y. So let's look at X first. So here we go. And X, right, you can see over here we have one. Oh, I should scroll up or scroll down over here on my screen. So you can see some of the data over here, but we have 1, 2, 3. So we have 4 different features associated with it. And just look up the feature data set on this side of things, or the iris data set in general for the features. It says that this is the length and width of the sepals and also the petals in centimeters. And essentially, we're going to be taking a look at this and determining what type of, it's like an iris flower or something like that. And there's 3 different types within this data set. So this is a little bit of a backstory on that. And how we can also tell that there's going to be 3. Let me create a new cell over here. Let's just put in our Y. So you can see we go 0, 1, and also 2. So let's take a look now at the shape for both of these. So we can just do x.shape and then y.shape. And if you are familiar with this data set, feel free to skip ahead a little bit. But I just want to present some things over here. So you can see over here, 150 total entries, right? So that's pretty good there. And then also our 4 features, and then our 1 final output, depending on the type of like flower, leaf, or whatever ends up being on that side of things. Again, I'm not 100% sure. All right. Now I just want to show you like what this data over here looks like kind of as a data frame. That way we can combine this stuff together. So this is gonna be pretty easy. You can just do iris like df like this, okay, equals pd.dataframe. And I almost didn't put this in the video, but I felt like it didn't hurt per se. So, all right, now we're just gonna do some basic pandas over here. So we'll just call it like x1, and over here we'll say x, colon over here, grab it 0, put a comma over here like that, and we're just gonna go across the board and do this for 2, 3, and 4. So 2, 3, and 4, and then also our y, but our y is gonna be a little bit different. So you can just do 2, 3, 4, make this a y over here, and then y is just gonna be y, and put a comma, remove that over here. I guess I could just done some other stuff, and assuming no issues over here, great. We'll just do a head of 10. So we'll put head 10 like this over here. And yeah, so right, we have our features like this, and this determines our specific y that's associated with it. So okay, great. Now, just from reading the data set, our value counts are going to be 50 for each. But if you wanted to see specifically what these value counts look like, pretty easy, right? Iris underscore df, you can just do .y .value counts, right? And I'll show you 50 across the board for these 3 over here. Awesome. Now, I want to show you some charts based around this. So I was lazy and didn't want to type or code all this out. So I just literally asked ChatGPT on this side of things. And this is the code that it spewed out. So they use that to save some time on this side of things. So you can just go over here and type this out. I will also put the notebook or my GitHub down below. And I know I need to upload more stuff to GitHub. I will do that maybe this weekend when I am actually recording this video. It's a holiday here in the States. So I got off work and I've been working on an app, which I can't talk too much about it yet until it launches, which hopefully Q2 next year. But we'll talk about that and some YouTube videos if it ends up being successful. With that being said, it is a reason why I'm not uploading 3 times a week. But I am still learning a lot on PyTorch, and I will continue to build this out. So the code I'm doing right now is just showing all the different feature combinations. So I mentioned that there were 4 different features. So we're going to have to build out 6 different charts or 6 different graphs. So this is just showing all the different, I think the technical term is like permutations. I remember this from a long time ago from like all the factorials and things like that. We have like 4 features, not to go off topic. 4 different things, it would be like 3 factorial, which is why it's 6. Correct me if I am wrong in the comments, and I can look dumb. Say that as I was one of the only kids that studied this stuff for math competitions in high school. All right, so get back on topic. Ignore my ramblings over here. We're just gonna continue doing this and zip. And like, don't worry too much if this code is confusing. Like, again, it's just graphing stuff. And what I'm trying to do is just put all 6 graphs next to each other just to show you like why we can specifically show the different combinations, like what's going on this side of things. And hopefully I didn't make any typos with this. There's just a few more lines of code. So if you don't want to type this out, don't do it. Fully optional. Put that over here. And if I do make an error, I'll probably just copy my example code, which I have right next to me. It's kind of nice, right? X feature 2. There you go. I do have an error here. Didn't close that out. Should be good with that one. And then set X label, which is going to be copy that code, do it for Y as well, which is going to be feature 2. That's okay. And then we just, like I said, we're almost done with the code. Do it. Do you want the title? Yeah, why not? And it should be like this. Feature 1. Okay. I'm going to say versus. And then it's going to be essentially feature 2. We don't need that. That's why we're having an error. Here. Don't need that. I think that should be good here. Then we're going to do a tight layout. Like this. And then just show it plt.show. I know this was a bit technical over here. But it's sometimes nice to see visually what's going on. And I have an error. X and Y must be same size. Let me just copy that line. Sure. Made a small mistake. Let's see now. There we go. All right. I had some type of bug over here. So essentially sepal length versus sepal width, sepal length versus petal length, sepal length versus petal width. So you can see like the 3 types of flowers. Like this one over here is just bunched there. This one's bunched over here. And essentially we're going to be building a deep learning model that's going to detect these and be fairly accurate. I think the first time I did this, I got like a 96% accuracy and a pretty low loss score. So with that in mind, let's start building out. And what I'm going to recommend is we train test split first, then we scale before we create our tensors. So let's do that. So I'm going to set X train, X test, Y train, and Y test equals the train test split like this. Then put your capital X, your lowercase y, test size equals 0.2, and then set a random state equals 42. I do have a question with this random state. I see all the time in tutorials people put 42, like a lot of technical tutorials. Why that specific number? I mean, like as a baseball fan, obviously Jackie's number, but just in general, I've always been curious with that. So that's why I'm just going to put 42 for this one. Up next, we're going to do scalar equals standard scalar. Okay. So we're just calling our standard scalar. You remember we imported that in a little bit earlier. So next, we're going to just set our X train equals over here, scalar dot fit transform, put our X train in there, and then X test equals scalar dot transform, and then you throw your X test in here like that. Okay. Now we have scaled our data, and scaling your data is pretty important when you're going to be running PyTorch and also deep learning models. One of the first things I learned. So if you want more accurate results, scale your specific data. Now, one more line of code before we get into building out our specific tensors. And what I'm going to be taking a look at is setting a specific device. I didn't do that in my first PyTorch video just because there's so much to cover with this stuff, but this is a very common line that you'll see in a lot of code, and it's whether you're going to run your code on the GPU or CPU. Now, this isn't going to take a lot of resources for the code I'm writing on this side of things, so I'm just running Colab with a CPU, but you do have the option to change it to a GPU if you want. So device equals CUDA if torch.CUDA over here dot is available like this, and else CPU. So this essentially says, like, we have a GPU available, run on the GPU. Otherwise, you're going to run on your CPU. And I'm just going to run that line of code. And you'll see where I add to device in a lot of different sections of the code. And that is why I wrote this over here. So if you want to run it on your GPU, feel free to do so. I'm going to make another video talking about this in the near future. All right, so now we're going to transform what we have. You know how we have the train and also our test over here. Well, these aren't tensors right now, so we need to change that up. So what I'm going to say is x train tensor equals, and I'm going to say torch.tensor. Then over here, we're going to put our x train. So this is what we're changing into a tensor. Up next, we have to specify our specific d type on this side of things. So put d type equals torch.float. And the reason why we're using float, if we go back up over here, right, we have a lot of decimals. So that's the reason why we're using float, okay? And what we're going to do is .2, and at the very end, we're going to put device. Now, this is going to create the tensor to whether you use a CPU or GPU, and that's why we have this line of code over here, right? So we push it specifically to that device. Now we're going to have to replicate this code a little bit, and let's do the same exact thing over here a few times. First thing we're going to change over here is the y train tensor, and we're going to change this up slightly. So for this d type, we have torch.float. This time, instead of float, we're going to put int64. And the reason why is if we go back up over here to our y values, we have 0, 1, or 2. It's not the best to put on float, right? We can use an integer instead. So that's why we're using int64. We can do the same thing over here, which is going to be our y test. So let's change that up to y test, and we'll put y test over here as well. So x train, y train to y train. This should be x test over here. So x test, and then you put x test over here as well. And now we're going to have our specific tensors. So let's run that and make sure everything's great. All right, so before we build out our class for over here, I just want to go through our code one more time just to make sure that you guys are understanding it correctly. So we imported our libraries in over here. We grabbed the iris data set, or set our x to the data, or y is to that specific target, right? And you can see specifically what's going on over here. Again, I did also just put this over here to a data frame. Don't need it for this problem, but just wanted to show you what was happening. Same with these graphs. Like, do you need it for this problem? No, but I want to show you what's happening on those. And then we try to split. We set up our scalar. We scaled our x train and x test over here, fit transform and also transform. Then we have code over here to create our tensors on a specific device, whether you have a CPU or GPU. And then we changed our train tests to specific tensors through this line of code, and we added to device over here. I know it's a lot, but we're going to continue to build upon this. So now what we're going to do is we're going to build out a class, and your knowledge of Python classes needs to be there a little bit. I do have a full video on it, like 2-3 hours teaching you Python classes. So if you're not too familiar with Python classes, I recommend watching that even before you get into this PyTorch or deep learning series or whatever this ends up morphing into. But highly suggest you watch that video. All right. So what we're going to do is we're going to say class. We're going to say a simple classifier over here. And then we're going to inherit. So the way we inherit is we put whatever we want over here, which in this case, we're going to inherit from nn.Module. And that's, we go back to the top. While we imported it in nn, that's where we're grabbing this stuff from, right? So, all right, we're creating our simple classifier, we're inheriting from nn.Module. Okay. So we're going to create a subclass. That's the technical term for it. Then we're going to create something that is called an init function, or it's really called a method, but outside of a class, it's a function, always called a method. So what's interesting on these are called like Thunder or Magic methods, and you're always going to have self with this on here. Then we're going to have in features, and then we're going to have our out features. So make sure you put those specifically in. Think about this, like what you're going to be putting into your model and what you expect to come out of your model. Then we have to have something called a super, and a super deals with subclasses again with inheriting. So make sure you have the super in here. We're going to do dot, and then we're putting this init over here. So double underscore, I don't know if I did that or not, init like that. Okay, so that's inheriting over here. And now we get into our specific layers. So I'm going to create 3 layers on this one. Well, last video I did 2 layers or 1 layer. I'm pretty sure. I can't remember. Either way, we're going to do 3 layers with this specific case, right? So we have self.layer1. We're going to say that's equal to nn.linear. And the first thing we're going to put over here, right, is whatever we bring in. So we can put our in features over here. And then I'm going to put another number. So I'm going to put 120 specifically here. Okay. Now we're going to create a hidden layer. And we're going to put over here as layer 2 nn.linear. Now, here's the deal. You see how we ended with 120 on the last layer? Well, because of that, we have to start with 120 with this layer. So whatever you end with the layer above, you have to make sure that is the first part of the next specific layer. Okay. So super important that you do that. Now I'm going to put over here that this ends with like 10, and we're going to create a layer 3, and you can continue to add on layers as you like. Now it doesn't always happen, but when you tend to have more layers, you tend to have a little bit more accuracy, and also raising this number over here and get a fairly more accurate model. Doesn't happen all the time, but does happen. So that's why I put this over here, and also kind of good to show you what's going on. So if you remember this, like what I showed you over here, we're going to have to start with 10. And what we're going to finish this with is our out features. So put your out features over here, right? And our out features are going to end up being the number of specific classes that we have. So you can see that we have like 3 that are going on over here, and that's essentially what our out features is going to end up being. All right. Up next, we need to set our forward method. You're always going to see forwards within PyTorch. So easy. You put a self, you put an X over here, right? Then what we're going to do is we have to have a return. I'm just going to set our X equal to self.layer3, and I'll explain my code in a second, why I'm doing this. So then we're going to say self.layer_2, which inside of that, we're going to have self.layer1, which is going to bring into the X. All right. And one more line of code for this. We're going to say return, and we're going to put inside our return X. Okay. So we have to run through all these specific layers, right? We have layer 1, layer 2, layer 3. So how this code works is essentially we have self.layer1. We put our X in here. The result of layer 1 gets inputted into layer 2. The result of layer 2 gets inputted into layer 3. Now, you could just go over here and say like X equals self.layer1. Then you can do self.layer2, self.layer3 in order. I've seen a lot of code like this, and it's a little bit more efficient just to write it in one line like this. I mean, a little bit quicker that way. I don't know for sure efficiency like with performance, but either way, that's why I wanted to show you. Do you like how I did it this way? My other video with linear regressions, I did it another way. So feel free to do what you want. And then I just return this here at the end. Okay, run it, and we are good. All right, so now we're going to have to take a look at our in feature, our number of classes, and also set up our specific model. So let's do that. So the first thing we're going to do is our in features over here, right? We're going to say that's equal to our X train, over here, dot shape, and then inside over here, we're going to specifically put 1. Now, what this is going to take a look at specifically is the number of columns on this X shape. It's not going to be taking a look at the rows. If we put 0 over here, it would be taking a look at our rows. 1 is going to take a look at the specific columns. And we're going to also make sure we have number of classes. We're going to say that's equal to the length. And this was new to me originally when I was coding this, but we're going to use something called set. Now, what set does is it converts a list to automatically remove any duplicates in here, leaving only unique values. So that's important because if we go back over here, what I talked about is we have 3 specific types of flowers or petals or whatever it ends up being, right? So we want to have our number of classes equal to those 3 specific unique flowers, and that's why we have this set over here. This finds a unique, right? It'll end up being 3, and then the length determines that 3. Hopefully that makes sense on why we're specifically doing that. Okay. And lastly, we're going to have to set our specific model up. So we're going to say model equals, and we called this above simple classifier. So put simple classifier in here. Great. Now we're going to have to put in our in features, right? So in features, then we put in our number of classes. We have that over here. And like earlier where we have this .toDevice, we can just paste this over here when you create your specific model. So again, in features, we go back to the code, right? We define our init over here, this specific method. We have to have our in features and out features. Yourself is this specific instance, so you never really have to have yourself, right? Like model is going to be that self. So we have to throw in here our in features and out features. We have our in features over here, and our out features, as I mentioned, is going to be our number of classes when we were going to be working with a multi-classification problem, and we got our number of classes over here. So that's why we put this over here. And toDevice, right? Our device over here, we called that. So essentially, we're going to bring this to the CPU. So let me run this, and we do have an issue. It says it takes 1 positional argument, but 3 were called. And the reason why is I only put 1 underscore over here. At least this is my thought right now. Let me just rerun this over here. And yeah, it's good to go. I thought I put 2 there, but always make sure you put 2 with the magic or dunder methods. Sometimes it looks like that from far away. But yeah, so now this is working. So again, to explain it, right? We inherited from nn.Module. We created this init method over here. Self is going to always be that instance. We have in features, out features. We need to have this super since we're dealing with inheritance. Then we created our 3 layers. Remember, output is input of the next layer. Okay, we have our forward over here. Again, we don't need our self. We just have our x and x.self layer 3. Again, we're going 1, 2, 3. We're just putting 1 over here. 2 grabs the input from 1. 3 grabs the input from 2, and we're returning that. In features, we set that up. We set up our number of classes, and now since we have our in features and number of classes, which is technically our out features, we set that to our specific device. All right. Next part of the code, I'm going to just add a few more lines over here. So we're going to set our criterion and also our optimizer. Our criterion is our loss function. Our optimizer is going to get our better performance. So criterion, we're going to say equals to nn.cross-entropy loss right here. And then we're going to set our optimizer equals optim.sgd. And up over here, our model.parameters. Like this, because it's going to optimize our parameters on the model. And then learning rate, I'm going to put 0.01, and feel free to tweak your learning rate. You'll get different performances based around that. And you can even change your criterion or optimizer to get better results or worse results. But this performed pretty well for me in this instance. So that's what I will be doing in this video. And man, I am all over the place with errors today. What's my error now? Simple classifier object has no parameters. Did I misspell it? should be correct. And I probably misspelled parameters. So there we go. All right, now we're going to create our specific training loop. So the first thing that we're going to do is set our epochs on here. So we're going to say number epochs like this. And this tells you how many times you're going to run this training loop. I'm going to do 1,000 for this video. You tend to get better results when you have a higher number of epochs. So now let's build out our training loop. So what we're doing is for epoch in range, I need to get number epochs. So it's going to go from 0 through 999. Now, one thing I didn't put in my other video, by default, our model is going to be in train mode, but it's better just to call this out. So I'm going to just put over here model.train, and we have that. First thing we're going to do is set up our forward pass. So what we're going to do is take a look at our outputs. We're going to say our outputs equals the model, and we're going to put in x train tensor. And that is this code over here, our x train tensor. Remember, we split our x into a train and test, and we create tensors. That's what we're putting first into our specific model. Now, what we're going to take a look at is our loss. So our loss is going to be equal to this criterion right here, right? So grab this criterion, and remember our criterion is going to be taking a look at cross-entropy loss. Now, over here, what we're going to do, our first thing we're going to do is put our outputs. So we have our outputs over here. And then what you're also going to be taking a look at is your y train tensor, which we have right over here. Now, why we're doing this. So we have our model over here that takes a look at your x train. It's going to have results, right? That's our outputs. Our loss is essentially going to be the difference between our outputs and also our y training tensor. And that's how we determine our specific loss. Now, the loss that we are doing is based off this criterion of nn.Cross-entropy loss. And it talks about the calculation over here, but this is how our loss is getting calculated, okay? A little bit confusing, I understand, but that's why we're doing that. Okay. Next, what we're going to do is take a look at building out our specific accuracy. So, all right, so now we're going to be taking a look at our accuracy score. So this code is a little bit confusing, but here's how we do this. The first thing we're going to do is we're going to put an underscore and a comma. This tells Python we're going to disregard one of these outputs. We're going to be taking a look at the torch max function. So we're going to put over here predicted underscore labels, which I don't know why it's caps. There we go. Like that. We're going to say equal to torch.max. We're going to put outputs and also 1. Okay. The next line of code that we're going to be using is our correct predictions. So we're going to say correct predictions equal. And over here, we're going to say our predicted labels has to be equal to our y train tensor. Then we're going to say the sum of this. And then we're going to do item. All right. So the item method extracts a specific scalar value from the tensor. And that's why we have our item here at the end. We're making sure our predicted label, right, our torch.max for their output is going to be equal to the tensor. We're summing that with our specific output on here with item. Okay. Now what we're going to do is find our total samples. So total samples equals the length of our y train tensor. Y train tensor. Okay. And lastly, our accuracy is going to be equal to our correct predictions. And then we're going to say divided by total samples. And I know this is a little bit confusing, but this is how we are going to calculate our specific accuracy. All right. Up next, what we're going to be taking a look at is essentially correcting our model and being able to keep going forward with it. And there's 3 lines of code that you're going to see essentially with every PyTorch model. And it's going to be optimizer.0grad, which stands for gradients. So all this stuff is getting calculated. Then you go backwards. So loss.backwards, or backward, I should say, not backwards. And then you do a step. So optimizer.step. A bit confusing at first, but like the more you practice, not too bad. And then if we want to see the result for every 10 epochs, we can just go over here and say epoch plus 1 over here. 10. The reason why we do that is it starts at 0. Remember that. So we're going to say equals 0. All right. And then we're going to say print. Put over here like this. We'll put epoch. That. And then we'll say over here on the inside, epoch plus 1 over here divided by, put over here, num epochs. It should be working there. Put a comma here at the end. We'll first do our loss, which should be a lot easier. So we'll put over here loss.item. And then you can specifically round it if you want. I'm just going to put 0.4f like this. All right. And then we're going to set our accuracy. This. So accuracy. And our accuracy is the pain to calculate. Our loss is easy, right? We have our loss dot here. Accuracy is a pain, man. So 0.4f like that. We should have our accuracy now. And we're having some errors. Let me just make sure. And I can't spell when I'm recording. But that should get that removed. And we can run this now. So no errors here, hopefully. Boom. All right. So awesome. So this is just our training sample, right? We didn't even take a look at our testing yet. So I'll show you. So the first time that this ran, right? Or not the first time, technically, the 10th time that we went through this over here, we had a loss of 0.818 and our accuracy was 0.7083. But then you took a look at 100, right? Our accuracy is 0.8667, but our loss is way down. So you can see we get quite a bit improvement over time. And then over here, our loss continues to go down a little bit, right? And our accuracy, it's kind of stabilized at 0.9667, but then it decreases a little bit, right? So about 970, we have our best over 0.9667 accuracy, and then a loss of 0.087, which is pretty good, I think, overall. I don't know if I did this data set, though, when I was running some of the machine learning models a little bit earlier this year. So I'd be kind of curious how they would perform with this. But either way, I do like that specific accuracy. So next, what we're going to do is take a look at the test data set. And what we're going to want to do first is change our models. So we had it in train, which deals with gradients. This time, we're going to set in evaluation mode. So we're going to say model.eval. And then what we're going to do as well is we're going to say with over here and torch.inference mode. So last time I showed a different way, which was no grad, but apparently inference mode is a little bit better as I've learned. So make sure you use torch.inference mode instead of 0 grad. Now, the first thing we're going to do is our outputs. So that's equal to model. Over here, we're going to throw in our x test tensor. Okay. And then up next is we're going to use this again, our 1 underscore, because we don't care about this. We're going to say predicted equals torch dot max. We're going to put over here outputs and 1. Okay. Now we're going to calculate our accuracy. So we're going to say accuracy equals accuracy score and y test. And then we're going to over here predicted .numpy. I couldn't use the scikit-learn version of accuracy score over here when we have in model train mode, but we can use our accuracy score when it is in eval mode. So I'm going to take advantage of that. And that's why our code is quite simpler down over here. Again, something I learned through some testing. Then we're going to go over here to our predicted tensor. We're going to say that's equal to predicted dot clone dot detach like this. So essentially what this does is it creates a specific copy of this tensor. All right. And then one more line of code that we need. So loss equals criterion. Then we're going to put over here our outputs. Great. And then we're going to put in our predicted underscore tensor. Great. And then lastly, what we're going to do is print out everything again. So print. Okay, we're going to say here loss. And then we're going to put over here loss dot item. That. And we're going to round this again. We'll say 0.4f. Okay. And then lastly, we're going to put our accuracy. And over here, we're going to put this, our accuracy. Say 0.4f. I think that should be it with the code, right? Ooh, we made a mistake. And that's, here we go. 100% accuracy on our testing data set. And our loss was 0.065. So to close it out, our final loss on this was 0.065, and we had a 100% accuracy on the testing data set. So that's it for this video. I hope you guys learned something brand new. And if you did, make sure to subscribe to the channel. It's 100% for free, but it does allow the YouTube algorithm to promote this video, as well as the channel, to other people that are getting into machine learning or deep learning, or want to improve their data skills altogether. Also, I have one other PyTorch video here on the channel, which is going to be on linear regressions. I will be expanding the series out, so expect new videos within the next few weeks.